All right, welcome to the wonderful world of parabolas. First of all, I want you guys to notice this equation. I have a y equals x squared. When it's a parabola, only one of your variables will be squared. So either the x will be squared, or look, I think it's on the back side of this page. Notice here my y is squared, not the x. So you're going to know if it's a parabola, if it's only one squared. Remember, a parabola kind of looks like a U, so you can kind of get a visual. So this is the standard equation, y equals x squared. And you're going to get to where when you see this, you just know what it looks like. I'm going to tell you right now that the vertex is 0, 0. But if you would forget, here's how you're going to solve this. Since you have solved for y, and let me just say this also, in your book they're not so nice, but whatever is to the first power, you need to get it by itself on the left. And the squared terms, get them on the right. Okay, but since it's solved for y, you're going to plug in values for x. Anything you want, anything. Just remember, you have to graph it. So if I plug in 0, my favorite point, when you plug in 0, 0 squared is still 0. So that gives you a point. If I plug in 1, 1 squared is 1. If I plug in negative 1, negative 1 squared is 1. How about 2? If you plug in 2, 2 squared is 4. The same thing if you plug in negative 2. And we'll do one more here. 3. 3 squared is 9, so obviously negative 3 squared is 9. Okay, so what you're going to do is you're going to go down here and you're going to plot all of this on this graph. What I have you do is plot 3 on one graph. So remember, you had the point 0, 0, you had 1, 1, and negative 1, 1. You had 2, 4, and I'm looking through my phone, so let's hope I can get the right spot here. And negative 2, 4. And then 3, 9, and negative 3, 9. Okay, so it's going to look something like this. I'm having a hard time looking through my freaking phone. 1, 2, 3. Okay, I think it's right there. Here's what I want you to be sure of. This is not a V. Remember, we graphed absolute value as a sharp V, and I am looking through my phone, so let's hope that I can do this. I'll start down here. This is like a nice, smooth, it's a curve, not a sharp point. It's going to go forever and ever, because realize if I plugged in 4, I would outcome 16. So it never ends, so I want you to extend this and put arrows on the end. So it's like a nice U. This is what a standard parabola looks like. Notice the vertex is at 0, 0, and I kind of ran out of room here, but here's my vertex, is 0, 0, so that's one of my answers. And the axis of symmetry, let me just say, notice right here that on this axis, it's the same on the right as it is on the left. And the equation of this, okay, it is the y-axis, but the equation of this line is x equals 0. Remember, vertical lines, like if it was right here, the line would be x equals 8. Here it would be like x equals negative 3. So the equation of this line is x equals 0. Let me go up here. So this is the answer for my axis of symmetry. Okay, now, what happens right here if I add 3? And eventually you're going to know what this does, and you're not going to have to plot as many points. I do want to see at least 3 points on every graph. But let's just plug in some points, see what happens, and I'm going to come over here just a little further to plot my points so I don't run into room here. But if I plug in 0, I'm going to get 0 plus 3, or 3. If I plug in 1, I'm going to get 1 squared is 1, 1 plus 3 is 4. If I plug in negative 1, I'm going to get 1 plus 3 is 4. So let's make sure I see it. Let's plug in one more. If I plug in 2, 2 squared is 4, 4 plus 3 is 7. And again, if I plug in negative 2, out pops 7. Okay, so when I graph this, I'm going to graph it down here on this same graph, which is going to be a little crazy. I'm going to plot the point 0, 3. So I'm going to come down here, and here's 0, 3. And you know what? I'm going to do this one in a different color. So here's 0, 3. Problem is it's with a pin, so let's hope I don't make a mistake. I'm going to plot the point 1, 4 and negative 1, 4. So I'm going to plot the point 1, 4 and negative 1, 4. And then I also had the point, what did we have up here? 2, 7. Right there. And negative 2, 7. Notice it's the same distance on either side of the y-axis again. So here's my parabola here. Looks very similar. Okay, and I'm going to label that this is number 2 right here. And I should have labeled right here This was number 1. So let me label my pencil one as number 1. So I want you to look at my original graph and my next graph, number 2. What did it do that's different? Do you guys see that it went up 3? So this is what's cool. When I get this right here and I've got a number tagged on the end, I would actually make this note to yourself. This is going to make it go up 3. So I'm trying to look at this next one over here. Okay, let's look later and see what this one does. But I'm just going to give you a little hint. When I get ready to graph this, since my x is squared, I do know it's going to be a parabola. But think if I added 3, it went up 3. Here I'm going to subtract 4. So it should go down 4. But when we do that one here in a minute, we're going to look at it and see what happens. Okay, so what is my vertex? My vertex is this low point right here, which is 0, 3. So that's my vertex. My axis of symmetry was still the y-axis, which is x equals 0. So those are my 2 answers there. So let's try this one. Now I want you to look really close. What is the difference between this one and this one? Because I'm adding 3 both times. Here, my 3 is like an afterthought. It's not involved with my x. This 3 is involved with my x. Remember, order of operations, it's going to mess with my x, and then I'm going to square it. So it's going to affect things, okay? Let's plug in some points and see what happens. I'm going to come over here to the side, plug in my favorite point. If I get 0, I'm going to get 3. 3 squared is 9. This would be another favorite point of mine, and I want you to look why, because I'm going to get 0 in here, and 0 squared is 0, okay? And let's plug in something else. If I plug in 1, 1 plus 3 is 4. 4 squared is 16. And let's plug in negative 1. Negative 1 plus 3 is what? 2. 2 squared is 4. Okay, so far I'm like, oh, I am not seeing much. So I'm going to keep working on this. I'm going to plug it in negative 2. Negative 2 plus 3 is what? 1. 1 squared is 1. And then let's plug in negative, we already plugged in negative 3. Let's plug in negative 4. Negative 4 plus 3 is negative 1. Negative 1 squared is 1. Okay, so finally, I have something that repeats right there. So I'm going to try a negative 5. So just keep plugging in points till you can see what's happening here. Negative 5 plus 3 is negative 2. Negative 2 squared is 4. And I'm like, okay, good. Now I've got some things repeating over here on my y, so I should be able to kind of see what's going on. All right, I'm going to graph this in a different color just so you can see it, but I have the point 0, 9. So I've got that point right there. I've got the point negative 3, 0. How about 1, 16? Woo, it's way up there, so I'm going to ignore him. Negative 1, 4. I've already got a point, but I'm going to put another point right there. Negative 2, 1, boop, right there. Negative 4, 1. Ooh, do you guys see that right there? Kind of. There's that U. I was looking for that. And negative 5, 4. 1, 2, 3, right there. Look how he's symmetrical with that one. Okay, so here as it is. And there's my parabola. I should look something. I'm going to aim up there for that red one. So this right here, I'm on number 3. I'm going to go ahead and label it. I'm going to extend this all the way out. So there it is. So here's what I want you to notice. Here was my original parabola. Remember my standard one? It was just y equals x squared. But when I added 3, it went left 3. That's crazy. Okay? So here's my vertex at negative 3, 0. So I'm going to put this in. Oops. Look at that. I put negative 30, 0. Negative 3, 0. My axis of symmetry is right here. Okay, so it should be the same on the left as it is on the right, and that is the line x equals negative 3. And by the way, this is no coincidence. Okay, notice my x value. And let me just say, it's because it's the x that's squared. We'll look in the back side here in a minute when it's not. So when it was on the inside and it messed with my x, this thing right here went left 3. So you might make yourself a little note what it did. It went left 3. So you would think it would go right 3 because you're adding 3, but when it messes with your x, it messes with your mind. Okay, I'm going to do these next 3 on a separate video,